All right, let's take a look at this Intro to Transformations practice. I am posting a blank copy on Schoology for you to annotate with Cami. And I'm also going to post an answer key for you to check your answers. But I do want to go over a few of these examples just to help you navigate some of this, since it's relatively new material for everybody here. So first, let's talk about translations here. Translations, as a reminder, are a slide, and that's what's going on here. As you can see here, if you connect A and A prime, B and B prime, and C prime, they're all sliding the same direction at the same trajectory. In other words, they're each going 3 units to the left and 1 unit down. 3 units left, 1 down. 3 units left, 1 down. So in fact, I'm going to start this process by writing a rule here. And the rule is going to go right over here, okay? And the rule for this is what I just said. So 3 units to the left, that means the x is getting smaller by 3 if it's going 3 to the left. So the rule would be x minus 3 right there. And then the y is going 1 down. So that means y minus 1 right here. All right, so there is my rule right there, my translation rule. It's a shift, 3 to the left and 1 down. Now I'm going to erase this, and that'll help us as we now kind of look at some of these points and how they're changing. If I can figure out how to erase it. It's not working right now. So I guess I'll just move forward here. So A is given to you right here. 2, 2 goes to negative 1, 1. So it's pointing out this point right here is going to this point right here, just stating the order of pairs. Now point B starts at 1, 0. That's right there. And it goes over to B prime right over there. That point is negative 2 in the x, negative 1 in the y. So we'd say arrow B prime, negative 2, negative 1. And C, in C, it starts at 3, negative 1, and it ends up right here on the y-axis at 0, negative 2. So we'd say arrow C prime 0, negative 2. Now I want you to notice something here. If you took the original points and applied these rules, this rule right here that we wrote out, if you applied that rule to the original points, you would get the new points or the image points. For example, look at point A. Point A is at 2, 2. If I subtract 3 from the x and subtract 1 from the y, what do I get? Well, 2 minus 3 is negative 1, and 2 minus 1 is 1. So I get negative 1, 1 for A. The same would be true for B and C. The last thing I want you to notice about this is a translation is an example of a rigid motion. These shapes are exactly the same size, same shape. It was just shifted. Next, let's take a look at a reflection over the x, and then next, a reflection over the y-axis, and see what that looks like. If I want to reflect over the x-axis, I'm trying to reflect over this line right here. That's the x-axis. So when I conduct a reflection, I need to go the same distance in the opposite direction of the line of reflection. So what I mean by that is start with with point A here, for example. We're going to do the same thing to each point, though. Notice that A is 1, 2, 3 units above the yellow line. So if I want to reflect it over that axis, I need to go 1, 2, 3 below that yellow line. So A prime is going to be right there. There's A prime. And A prime is located at the coordinate 1, 2, 3, 4, 1, 2, 3. Again, the way I got that 1, 2, 3, 4, 1, 2, 3. So that would be 4. A prime is at 4, negative 3. Just like that. Now let's do the same thing with the other points. D is 1, 2, 3, 4, 5 units above the x-axis. So I need to go 1, 2, 3, 4, 5 below the x-axis to get D prime. There's D prime. So D prime was at 1, 5, or so D was at 1, 5. D prime is at 1, negative 5. Notice the pattern here. It's the x opposite of y pattern. The x stays the same and the y goes opposite. Let's do M and W as well. M is 1, 2, 3, 4, 5 units above the x-axis, so we'd go 1, 2, 3, 4, 5 below. And that is going to be at M prime is at -1, -5. Again, the x stayed the same, the y went opposite. And lastly, for W, it's 4 above 1, 2, 3, 4, so down 1, 2, 3, 4. So there's W right there, and W is at -1, -4. Now, if I connect those points that I just made, check this out. Same exact shape, it was just reflected over the x-axis, the yellow highlighted line. Now, how does that change if I reflect over the y-axis here? New shape, y-axis is the green line here. Here's the y-axis. So there's my line of reflection, okay? So I'm going to do the same thing, but I'm going over the y-axis instead of the x-axis. So let's start with I. I is 1, 2, 3, 4, 5 units to the left of the green line. So I'd have to go 1, 2, 3, 4, 5 the other direction to find I prime. So here is I prime, and that is going to be at 5, -1. So I prime, 5, -1. So it looks like the x went opposite, but the y stayed the same. Let's go to P. P is 1, 2, 3, 4 to the left, so 1, 2, 3, 4 to the right. There's P prime. So P prime is at 4, -2. I think you can see kind of how this is going to play out. I'm just going to graph the last couple. So S prime is going to be over here, and W prime is going to be over here. Connect those. There's my new shape. It's a reflection over the y-axis. S prime turned out to be at 2, +1. W prime turns out to be at +2, +3. So again, the x switches signs, the y stays the same. Again, it's a rigid motion. These shapes are congruent shapes. Just a reflection over the y-axis does not change the size or shape of the figure, so they are still congruent. Last thing I want to talk about today is rotations. We talked a little bit about the rotation rules in our class activity Thursday or Friday. And I just want to remind you of those rules first of all. The 90-degree rotation rule is opposite of y, x. The 180-degree rotation rule is opposite of x, opposite of y. And the 270 rotation rule down here is y opposite x. So we're going to apply these rules to conduct these rotations. Now, I'm not going to do all 3 of these. I'll do one of them, maybe get you started on the other 2, and see if you can finish it up and check the key. So for a 90-degree rotation, it looks like A starts out at 4, 2 in this first problem in the upper left corner. That's the one I'm looking at now. A is at 4, 2, so that's right there. And if I rotate at 90 degrees and apply the rule opposite of y, x, so that means the opposite of y becomes my x. So the y is 2 in the original, so that becomes -2 here. And the x is 4, it stays 4. So 2, 4 is where A prime is going to be. So I go to 2 in the x, 4 in the y. There's A prime up there. There's the point. Oh, that's not correct. I need to go to -2, 4. So -2 in the x, up 4 in the y. There's A prime. That looks a little better. Now let's look at B prime. Opposite of y, so 1 becomes -1, and the x stays the same. So it's currently -1, it stays -1. So B prime is at -1, -1. So there's B prime. And lastly, C prime. C is at 2, -2. Opposite of y would be +2, so -2 goes to +2, and the x is 2, it stays 2. So 2, 2, there is C prime. Connect my 3 points. And there we have a 90-degree rotation counterclockwise, a 90-degree counterclockwise rotation. I'll start 180 and 270, but I want you to finish them, okay? So for A, A starts at 4, 2. If I apply the rule opposite of x, opposite of y, then A double prime would be -4, -2. So you just switch the signs for both. For 270, the rule is y opposite x. So for A triple prime, y is 2, so it stays 2. Opposite of x, so 4 becomes -4. All right, so there's where A triple prime would be. I want you all to try to finish the B's and the C's for 180 and 270 and graph those. And then check the key and make sure everything looks good. All right, everybody, thanks. Catch you next time.